All right, so in this video, we want to look at the secant and cosecant functions and what they would look like. So let's first go ahead and take a look at secant, which remember is going to be 1 over the cosine. So 1 over cosine of x. Now you see it's kind of similar to tangent and cotangent in that it has a series of asymptotes, but now instead of going from positive infinity down to negative infinity or vice versa, it's each period is going to stay on its side of the x-axis. So it's sort of a series of parabola-like shapes. So now, noting that since this is 1 over cosine, we do have a point at 1 where the angle is 0, and it's going to be the inverse of cosine. So wherever we were used to cosine coming back to the x-axis, we now have an asymptote. So again, the period of that would normally be 2 pi because when we're looking at our asymptotes, 1 over cosine of x, wherever cosine of x is 0, that occurs at points of pi over 2, 3 pi over 2, etc. So we have asymptotes occurring at every odd integer times pi over 2. So now when we squeeze that in by a factor of 2, since this angle has 2x, we're going to be looking at asymptotes wherever the cosine of 2x would be 0, or wherever the cosine of 2x is undefined, and that's going to occur again where these are squeezed in half, so that's going to look like pi over 4, 3 pi over 4, 5 pi over 4, etc. So just to verify that, let's go ahead and also bring up, and remember, since it's negative, it's also going to flip it over the x-axis. So if we bring up negative 1 over cosine x, and there's our original secant x. Now we have our other function. I think I forgot to put the 2x in. I was wondering why it was looking the same there. Sorry about that. Let's try this with negative secant of 2x essentially. So here again is our original secant of 2x, and then the negative is going to flip it over and squeeze it in so that it has half of the period it normally would. Now, just like the sine graph is essentially the cosine graph shifted, the cosecant graph is also going to be a shift of the secant graph. So let's actually look at a picture of that first by putting the 1 over sine of x into the calculator. As you can see, it's very similar looking, only now instead of crossing the y-axis at 1, it's been shifted because we know that sine of 0 occurs at 0, and sine has a maximum at values of multiples of pi over 2. So now we want to essentially shift this graph to the left, pi over 3, because we're adding it inside the function. So if normally, if we look at y equals cosecant of x, normally the asymptotes would occur where our sine of x is 0. So we would have asymptotes at points like 0, pi, 2 pi, etc. So now if we're shifting it to the left, pi over 3, we're going to subtract pi over 3 from these asymptotes. So we would have essentially negative pi over 3. Pi, remember, would be 3 pi over 3. So 3 pi over 3 minus pi over 3 would be 2 pi over 3. Or you can think of it, since I'm adding pi each time, I'm essentially adding another pi each time here. So 2 pi over 3 plus another pi would be 5 pi over 3. So now we've got y equals cosecant of x minus pi over 2. Let's see if you can determine what your asymptotes would be here.